Storage area networks are a little bit different than Ethernet networks. It's not the wild, wild west. Devices actually have to log into the fabric in order to use the storage area network. The first step, or the fabric login, sometimes called a FLOGGY, determines the presence or the absence of a fabric. If the fabric exists, it exchanges service parameters with the fabric. The switch identifies the worldwide name in the service parameters of the accept frame and assigns a fiber channel ID. It then initializes buffer-to-buffer credits. We'll learn about those later on, but those help ensure that we have a lossless fabric. Once the device is logged into the fabric, it then needs to create a port logon, or a PLOGGY. This is required between two nodes that want to communicate across the fabric. Similar to a FLOGGY or fabric login, it transports a port login frame to the designation node port. In a point-to-point topology, no fabric is present and it's a point-to-point topology, then we just skip that process and initialize buffer-to-buffer credits. Now, I mentioned during that process that there were fiber channel IDs assigned. These fiber channel IDs are kind of like an IP address on an Ethernet network. A fiber channel ID is assigned to every worldwide port name corresponding to a node port. A fiber channel ID is made up of a switch domain, an area, and a device. The domain ID is native to a single fiber channel switch. So for instance, in my graphic you can see that one switch has a domain ID of 5 and the other one has a domain ID of 12. There are a limited number of domain IDs in a single fabric. So there's a theoretical number that's over 200, I believe around 236, and there is a tested number which I believe is around 75. Forwarding decisions across the fabric are made based on that domain ID by a routing protocol called FSPF. Forwarding decisions are made based on domain ID by a protocol in the fabric services called FSPF, or Fabric Shortest Path First, similar to what OSPF is used for as a routing protocol on an Ethernet network. FSPF provides routing services within any fiber channel fabric. It supports multipath routing and bases the path status on the link state protocol similar to OSPF, as I mentioned before. It routes hop by hop based only on the domain ID, and there's one domain ID per switch and up to 75 per fabric. Once you use all 75, you're all done. So we have ways of getting around that called NPV, which we'll explain later on. The FSPF protocol runs on the E ports or expansion ports or the TE ports or the trunking expansion ports, basically the inner switch links between the devices, and it ensures a loop-free topology. It also runs on a per vSAN basis, so there's one FSPF protocol running for vSAN 1 and another one running for vSAN 2, and they're each keeping track of their own topology, which is why there is a limit to the number of fiber channel domain IDs. This protocol uses a topology database to keep track of the state of the links on all switches in the fabrics and associates a cost with each link. You can modify that cost to try to steer traffic in the direction you would like it to go. There is also a directory server or a name server, and that is similar to DNS on an IP network. The directory server is a repository of information regarding the components that make up a fiber channel network. Components or devices can register their characteristics with the directory server. For instance, I can say I'm a storage device or end node. That lets endports query the directory server for specific information. All of these are services that run on your Fibre Channel network and are important to know what these services do and what they're used for. Please join me for the next lesson, Understanding Initiators and Targets.